Hey future computer scientists! Welcome to day 2 of our 100-day journey into computer science. Look around you, chances are you're using a computer right now, whether it's a smartphone, a tablet, or a laptop. They're everywhere, shaping our lives in countless ways. But have you ever stopped to think, how did we get here? What's the fascinating story behind these incredible machines? Today, we're taking a trip back in time to explore the history of computers. Our story begins not with wires and electricity, but with ingenuity and human need. For millennia, people needed tools to count and calculate. Think about the abacus, used thousands of years ago, a simple, yet powerful device for arithmetic. Fast forward to the 17th century, where brilliant minds like Blaise Pascal invented mechanical calculators, like the Pascaline, which could add and subtract. Leibniz later improved on this, building machines that could multiply and divide. These were complex gears and levers, true marvels of their time, and they laid the groundwork for future innovations. Perhaps the most visionary figures of this early era were Charles Babbage and Ada Lovelace in the 19th century. Babbage designed the analytical engine, a general-purpose mechanical computer, decades ahead of its time. It had an arithmetic logic unit, conditional branching, and even loops, concepts fundamental to modern computers. And Ada Lovelace, Lord Byron's daughter, saw its potential beyond just number crunching. She wrote what's considered the first algorithm intended to be carried out by a machine, making her the world's first computer programmer. They were designing a computer before electricity was even widely harnessed. The real explosion in computing happened in the mid-20th century. World War II spurred the desperate need for faster calculations, leading to the development of the first electronic computers. Machines like the Colossus in Britain and the Harvard Mark I in the US were massive, room-sized devices using electromechanical relays. But the true game-changer was the ENIAC, the Electronic Numerical Integrator and Computer, unveiled in 1946. It used thousands of vacuum tubes, generating enormous heat and consuming vast amounts of power, but it could perform calculations thousands of times faster than anything before it. Soon after came the UNIVAC, the first commercial computer, which famously predicted the 1952 presidential election. Vacuum tubes were inefficient giants. A revolutionary invention came in 1947, the transistor, developed at Bell Labs. Transistors were tiny, reliable, and consumed far less power. This innovation led to second-generation computers, which were smaller and more powerful. Then, the integrated circuit, combining many transistors on a single silicon chip, led to third-generation computers. This miniaturization was absolutely key to making computers practical and eventually, personal. And that brings us closer to home. The 1970s and 80s saw the birth of the personal computer. Companies like Apple, with the Apple II, and later IBM, with the IBM PC, brought computing power to homes and small businesses. Suddenly, computers weren't just for governments or huge corporations. People could run their own programs, play games, and manage finances. The introduction of the Graphical User Interface (GUI) by Xerox PARC, popularized by Apple's Macintosh, made computers even more accessible, moving from typing complex commands to simply clicking icons. It was a true revolution, putting computing in the hands of the many. The final, monumental leap came with the Internet. What started as ARPANET for military and academic use evolved into the World Wide Web, invented by Tim Berners-Lee. This connected computers globally, creating the information age we now live in. Then came mobile computing, putting supercomputers in our pockets, followed by cloud computing, artificial intelligence, and machine learning. Today's computers are astonishingly powerful, constantly learning and evolving, pushing the boundaries of what's possible. So, what an incredible journey! From simple counting tools to room-sized behemoths, and finally to the sleek, powerful devices we use today. We've seen how human ingenuity, driven by a need to calculate and process information, has continually pushed the boundaries of what's possible. Each step, from gears to vacuum tubes to transistors and silicon chips, built upon the last, culminating in the connected, intelligent world we inhabit. But how do these amazing machines actually think? What's the fundamental language they speak? Tomorrow, on day 3, we're going to dive into the absolute core of computing, binary numbers and data representation. Get ready to understand the zeros and ones that make everything work. See you then.